Starting from question 21 onward. In question 21, the period of a periodic table is shown. The letters are not their chemical symbols. Which statement is correct? You can also use a chat to state the answer. So these are elements R, S, T, V, W, X, Y, and Z. The element R does not conduct electricity. That is wrong. Why? Because this will be a metal. And what is a characteristic of the metal? Metals can conduct electricity. Element R and Y react to form an ionic compound. So R is a metal and Y will be a non-metal. And whenever metal and non-metal combine with each other, what will be the type of compound which is formed? That is the ionic compound, which is formed due to the complete transfer of electron from the metal to non-metal. So B is the right answer. Why not C or D? Element Z exists as a diatomic. Element Z is a group 8 element, and what is the characteristic of group 8 element? They're existing as a, they are non-metals, and how these non-metals are existing? They're existing as a monoatomic element. And Z reacts with element T. So Z is group 8, it has a complete shell, so it does not react. That's why D is also incorrect. Question 22. Group 7 elements show trends in their physical properties as we go down. Like we have chlorine, bromine, and iodine. Which row shows the missing heading for the properties in the table? So as we go down the group, what are the like melting point or boiling point for these halogens? As we go down the group, it increases. So here minus 101, minus 7, and 114. So it means it is increasing. So X can be a melting point or a boiling point. Then what about Y also? Minus 34, 59, and 184. So it is increasing. So it can be a melting or boiling point. And what about the states? When we check the state, chlorine is a gas, bromine is a volatile liquid, and iodine is solid. So as we move down the group, the density also increases. So which row shows a missing heading for the properties? So one is representing a melting point, and that is in degree centigrade. Another one is a boiling point, that is also degree centigrade. And the third one representing a density. Density also increases, but the variation of a density is more as compared to change in the melting or the boiling point. And why X and Y cannot be density? Because density cannot be negative. You don't define a density as minus 101. That is totally incorrect. Density is mass present in a unit volume, so it will always be positive. So that's why Z is a density. So the column which includes Z as a density, either B can be an answer or C can be an answer. Then when you check the state at room temperature, when we are checking the state at a room temperature, chlorine, bromine, chlorine is gas at room temperature, which is like room temperature is 25. So where 25 will come in this order. So 25 will be here. For bromine is a liquid, so 25 will be here. And iodine is a solid, so 25 before the melting point. So the first one is a melting point, second one is a boiling point, and the third one is a density. So melting point, boiling point, and density. That's why B is the right answer. And it is obvious that why the second column, Y cannot be a melting point, because the melting point cannot be higher than the boiling point. So melting point is always lower than the boiling point. That's why option B is the right answer for this. In question 23, some properties of two metals G and H are shown. As you can see, metal G, formula of the compound is GCl. So it shows that the valency, because chlorine is group 7 -1, so G should be +1. And it reacts with cold water. So this gives an idea, the element which a +1 valency and can react with cold water, they are alkali metals. Metal H is having a high melting point, has more than one oxidation state. So this gives an idea that it is a transition element. So which row about the metal G and H is correct? So what about metal G? Metal G is in group 1 of a periodic table. And what about metal H? Metal H is the transition element. So that's why option B is the right answer. Because the characteristic of a transition element, they have a variable oxidation number. Question 24, the noble gases in group 8 element are group 8 of the periodic table. Which statement explain why noble gases are unreactive? While they are unreactive, they have a complete outer shell. Like in the outer shell, they have complete electron. So they all have 8 electron in outer shell. This statement is not valid for helium. Why? Because helium is also a group 8 element, but it does not have 8 electron. It has only 2 electron in the outer shell. So because their outer shell is full or complete, that's why they're unreactive. So they all have a full outer shell. So B is the right answer. They all are gases. That is true, but that is not the reason why they're unreactive. And same thing, they all are monoatomic. Why they are all monoatomic? Because they have a complete shell, and that complete shell make them monoatomic or make them unreactive. So B is the right answer for this one. Which statement correct for all metals? So all metals, they can conduct, metals can conduct electricity in a solid or a liquid or molten state. So A is right. They gain electron when they form ions. That is wrong, because metal tend to lose electron, not gain electron. They have low densities. Metals usually have high density, except for group 1 alkali metals. And they have low melting point again, except group 1. These all metals have a high melting point. So not all the metals have low melting point. Most of the metals have high melting point. In question 26, which statement about the extraction of metal is correct? Aluminium is extracted from the ore bauxite by electrolysis. Yeah, that is true, because the ore of aluminium is bauxite and we do electrolysis. Aluminium is extracted from ore hematite. Hematite is not the ore of aluminium, it is the ore of iron. Iron is extracted from the ore bauxite. That is wrong, because iron we are not, that is aluminium ore, and that is not by electrolysis. How we extract the iron? We extract the iron by heating with coke or carbon in a blast furnace. In question 27, aluminium object do not need protection from a corrosion. Iron object must be protected from corrosion. Which is statement explain why aluminium resists corrosion? So why the aluminium resists corrosion? Like if we have a piece of aluminium, so the layer, the top layer of aluminium reacted with the atmosphere, the surrounding, and it turned into aluminium oxide. So there's a protective oxide layer on the aluminium. That's why it does not corrode or it does not react easily. But in case of iron, when it reacts with the surrounding oxygen and water, it forms rust, and then the layer of a rust removed from the surface, which expose the inner part of iron. Question 28. Which statement about the thermal decomposition of a copper to nitrate is correct? So when we heat copper to nitrate, it gives copper oxide, metal oxide, it gives nitrogen dioxide, the brown gas plus oxygen. So This will be copper oxide is a black solid which is formed. Nitrogen dioxide is a brown gas. It's an acidic gas and it is brown in color. And oxygen, it is having a tendency to relight the glowing splint. So a brown gas is given off when we check this statement. Statement 1 is correct because nitrogen dioxide is a brown gas. A gas which relight the glowing splint is also given off. That is a characteristic of oxygen. It relight the glowing splint. The solid residue is acidic oxide. That is wrong because it's a metal oxide. Metal oxide cannot be acidic. Either it will be basic or amphoteric. So statement 1 and statement 2 are the correct statements. So metal oxide can be basic or amphoteric, and non-metal oxide can be acidic or neutral. In question 29, covering iron with zinc prevent the iron from rusting even the zinc is scratched. Like if the layer of the iron, if we have iron and we place a layer of a zinc or cover it with a zinc, it prevent the iron from rusting. So even the layer is scratched. Like example, this is a piece of iron. And we are protecting this by placing a layer of zinc. And this technique is known as galvanizing. Say it is completely protected by covered with a layer of a zinc. But what if part of the layer is scratched or removed? Then what will happen now? Iron is exposed to the atmosphere. If iron is exposed to atmosphere, even though iron is exposed to the atmosphere, but it will not rust. Why? Because zinc is more reactive than iron. So zinc will oxidize or lose electron, and it will prevent the iron from rusting. So covering the iron with a tin prevent the iron from rusting, but when the tin layer is scratched, iron underneath start to rust. Now what happened? If the same iron is there and we covered with a layer of tin, so if it is completely covered with a layer of a tin, it will protect the iron from rusting. But if the layer is scratched or a part of a layer is removed, it cannot prevent iron from rusting. Why? Because tin is less reactive. So tin is less reactive than iron. Is this time the electron travel from iron to tin, and iron will react instead of tin. And here what happened? Electron transfer from zinc to iron. So zinc will react instead of iron. So when we use a more reactive metal surface, so both tin and zinc prevent iron from rusting by sacrificial protection. Sacrificial protection means that there should be a more reactive metal attached to iron, but tin is less reactive. That's why this method is not called sacrificial protection. Both tin and zinc prevent iron from rusting by stopping the water and carbon dioxide. Basically, for rusting to occur, not carbon dioxide, it should be oxygen. Tin is more reactive than iron, so that is totally wrong. And zinc loses electron more readily or easily than iron and prevent the iron from rusting. That is true. So zinc is oxidized instead of iron. That's why the zinc prevent iron from rusting. Because if iron rust, iron should be oxidized or iron should lose electron. But when it is protected by a layer of a zinc, zinc is losing electron. So it is preventing the iron from rusting. In question 30, which statement about the Haber process are correct? One of the raw material is extracted from a liquid by fraction distillation. That is true because we use the raw material is nitrogen and hydrogen. And if the raw material is nitrogen and hydrogen, so one of the raw material, nitrogen, we are extracting from the air. So this statement is correct. And that by fractional distillation, that is also true. One of the raw material is produced by reaction of steam with methane. Steam react with methane, it gives off hydrogen, so that is also true. So the first one will give us the nitrogen and the second one will give us hydrogen. The catalyst for the Haber process is vanadium pentoxide V2O5. That is wrong. This is a catalyst for a contact process, not for the Haber's process. So statement 1 and statement 2 are correct. That's why B is the right answer. Which raw material is used in a contact process? Contact process we use, like it is used to prepare sulfuric acid, manufacture of a sulfuric acid. So what are the steps which are involved? So first sulfur react with oxygen to give sulfur dioxide. So, and then sulfur dioxide react with more oxygen. The reaction is reversible, gives sulfur trioxide. So from where we get this oxygen is from air. So the raw material which is used, the sulfur and air. So A is the right answer for this. Question 32, lime, which is calcium oxide, is used to treat the waste from wastewater from the factory. Which substance is removed? Lime, which is a calcium oxide or a metal oxide, so it is a basic oxide. And basic oxide, it can react with acid. So ammonia, no. Why not? Because ammonia is alkaline gas, so it cannot react with basic oxide. Can react with acid. Sodium chloride, it is a salt solution, but it is a neutral solution, so it does not react. Sodium hydroxide is an alkali or the base. Sulfuric acid, so it is an acid. So acid can react with metal oxide or base, so D will be the right answer. Question 33. An alkane molecule which is having a molecular formula of C8 and H18 undergoes a cracking. So the substance R has 2 carbon atoms per molecule and decolorizes the bromine. So decolorizes the bromine. This is a characteristic of alkene. Alkenes can decolorize bromine. And the substance R is having 2 carbon atoms. So which alkene, the formula of alkene, which is having 2 carbon atoms, the general formula of alkene is CnH2n. So R is actually an alkene. So N is equals to 2, so C2 and H4. So means this equation will be C8 H18 gives Q plus 2R. So 2 and R is C2 H4. Now we have to find what is the formula for Q. So how we can work out the formula of Q, because the total number of carbon atoms on the left and the right hand side should be equal or same. So on the left hand side we have total 8 carbon atoms. So if on the left hand side we have 8 carbon atoms, on the right hand side we should also have 8 carbon atoms. 2 multiplied by 2, 4 are already there. So how many carbon should be there? 4, because total should be 8. And total number of hydrogen should be 18 on the left and the right. So we have already 2 multiplied by 4 is 8 are there. So how many hydrogen we are left with? 10. So we are left with C4H10. And C4H10 is what? C4H10 is alkane, because the number of the hydrogen are twice plus 2 the number of carbon. And which alkane? How to identify the type of alkane? Because 4 carbon atoms are there. So whenever 4 carbon atom, the prefix which we use for 4 carbon atom is here. And because they have a single bond, so it will be N. So butane, so Q is actually butane. So from the first information, we work out the formula of R, and using the formula of R, as this equation is for cracking, so we work out the formula for Q. In question 34, fuel X produce carbon dioxide and water when it is burned in air. So does fuel Y? What could be X and Y? Because fuel X is producing carbon dioxide and water and fuel Y. So it means both should be a hydrocarbon. Because hydrocarbon, when we burn a hydrocarbon, it can produce carbon dioxide and water. If it is only a carbon fuel is there, it will produce carbon dioxide. If hydrogen fuel, it will only produce hydrogen. So it should be a hydrocarbon. So when we check X is not a hydrocarbon, Y is not a hydrocarbon, X is not a hydrocarbon, Y is. Here X is hydrocarbon, not Y, and here X is hydrocarbon, Y is also a hydrocarbon. So D will be the right answer. Because when we burn hydrocarbon, it produces carbon dioxide and water vapors. Next question 35. Which molecule contain only a single bond? So we will draw the structure of each organic molecule. So prop means 3 carbon and N means they will have single bond. And remaining because it's a hydrocarbon, so remaining hydrogen will be there. So you can clearly see the first option, propane contain only single bond. Why not propanoic acid? Because if I draw propanoic acid, prop means 3 carbon and oic acid means C double bonded with O and OH. So propanoic acid does not, it contain a double bond is there between, so it cannot be an answer. A is the right answer, we already marked. Then why not propene? Prop means 3 carbon and ene means there is a double bond. So this will have 2 hydrogen, this will have 1 hydrogen, and this will have. So propene cannot be because there is a double bond present. And why not propyl propanoid? So that is an ester. So how to draw an ester? C double bonded with O and O. First we draw the functional group. And propyl, prop means 3 carbon. So we draw 3 carbon with oxygen. And propanoid means 3 carbon, including this with a carbon chain. So when we put the hydrogen, this will have 2 hydrogen. This will have 2 hydrogens, and this will have 3 hydrogen. And here this will have 2 hydrogen. This will have 3 hydrogen. So there is a double bond because C double bonded with O is there. So in the question they are asking which contain only a single bond. So alkanes, they have only single bond. In question 36, alkane react with chlorine to form a chloroalkane. Which statement about this reaction of alkane with chlorine is correct? This reaction is known as a substitution reaction. So what happened, like any alkane is there, example we have methane C4CH4 reacted with chlorine. So 1 chlorine enter and 1 hydrogen leave. As a result, it will form CH3Cl plus HCl will be there. So when we check the statement, alkane react with chlorine by addition. That is wrong. This is not an addition reaction. This is substitution reaction. The gaseous product turn red litmus blue. This gaseous product, hydrochloric acid or hydrogen chloride gas is there. Hydrogen chloride gas is acidic, not basic, because red litmus to blue, it means basic or alkaline, but that is not right. It is an acidic gas. The chlorine atom in chloroethane are covalently bonded. That is true. Like in chloroalkane, the bond between carbon and the chlorine, it's by sharing of electron. So it is a covalent bond. So C is the right answer. And the general formula of chloroalkane is CnH2nCl. That is wrong as well, because the general formula of chloroalkane is CnH2n plus 1 Cl. Like the number of the hydrogen are twice plus 1 as compared to number of chlorine, the number of carbon. So like example, if there was C3, then how many H? 3 multiplied by 2, 6 plus 1, 7. So C3H7Cl will be there. If there was C2, then how many hydrogen? 2 multiplied by 2, 4 plus 1, 5. So C2H5Cl will be there. The part of a structure of a large molecule, this is a polymer is there. Which term describe a small unit? So small, what is the meaning of a small unit? Small unit is known as the monomer. So because a long chain compound, and this is a additional polymer. Addition polymer is there because it is linked like by a carbon chain. Like all carbon are attached with each other, so it is addition polymer. What from which compound it is formed? How we can work out from which compound it is formed? So we can simply hide, just take the first two carbon atoms and we'll draw a bond between them, so it will be a monomer. So this molecule, which term describe a small unit which make to this molecule? So what we call this small unit, we call that as a monomer. But if they join together, what we call this? We call this as a polymer. And this is an addition polymer, which is formed by breaking of a double bond and the small molecules link with each other. So this is the polymer, but in the question they're asking a small unit to make this molecule. So small unit is called monomer. They're not asking about specifically this structure. They're saying which structure combined to form this. Then propene react with steam to produce propanol. Which type of reaction is taking place? Look, whenever two or more reactants are there and only one product. When many reactants join together and form only one product, what we call that as addition. So A is the right answer. In question 39, which statement about the aqueous ethanoic acid is correct? Ethanoic acid is a weak acid, but it can react with, like it has all the characteristics as the acid, like it can react with metal oxide. Reaction rate of a reaction will be slower, but it can react with all these substances. So which statement about aqueous ethanoic acid is correct? It reacts with magnesium to produce salt and hydrogen. That is true. That is a characteristic of acid. When acid plus metal gives salt and hydrogen. So A is the right answer. Why not B? It reacts with sodium hydroxide to produce salt and hydrogen. That is, it produces salt but not hydrogen. It should be water, because acid react with the alkali base. It will produce water. It reacts with ammonium salt to produce ammonia. This is not a characteristic of acid. This is a characteristic of alkali. And it turned red litmus paper blue. This is again not a characteristic of acid. This is not a characteristic of acid. This is a characteristic of a base, because that turned the red litmus turned blue is for base or alkali, not for acid. Acid turned blue litmus paper red. So that's why A is the right answer. The last question, this is a polymer, polyester is there, thyrylene. So which monomer or which pair of a compound is made from it? So this is an ester, like there's an ester linkage, C double bonded with O. So when there is an ester linkage, it means it should be formed from carboxylic acid and alcohol, because a carboxylic acid and alcohol can react to form an ester. So when we check, like, or this is a carboxylic group and alcohol, A can be an answer. Why this is wrong? Because like it is dicarboxylic acid, polyester is formed, and dicarboxylic acid reacted with diol. Like two molecules, to both ends, we should have a carboxylic group. And for alcohol, both ends, diol means both ends, we should have OH. And between them, there's a carbon chain. So we can represent by a box. So there should be dicarbo. So why this is wrong? Because one side OH is there, one side carbo. That is why it is wrong. C can be an answer because there is dicarboxylic acid and diol, and then D cannot be. So we are left with either A can be an answer or C. Now we have to check if they react with each other, because dicarboxylic acid and diol will result in a formation of a polymer. Now when carboxylic groups are there, like example, as you can see here, so if one side we remove OH, the other side will be H. One side OH, the other side will be H. So when we draw the structure of a polymer, due to this, so it will be C double bonded with O. Then there will be a box which represent a carbon chain. Then there is C double bonded with O, OH and H being removed, so this will be O. And now the box will be shaded. And then O will be there. So you can clearly see this matches, like near the, around the box, the unshaded box, there is C double bonded with O. And around the shaded box, there is O. So it matches with the polymer of A. That's why A is the right answer. Why not C? When I check the polymer, it will form a polymer, but why not C? So when I draw the structure of a polymer, one side I will remove OH, the other side I will remove H. One side OH, the other side I will remove H. Now when the polymer is formed by this, the combination of these molecules, so this will be, then there will be a box, then O will be there, then OH is removed, so C double bonded with O, and then there will be a box, but a shaded box, and then C double bonded with O. So you can see if the polymer, it will, C will also form a polymer, but the polymer, if it is formed by C, then unshaded box is attached with oxygen and the shaded box is attached with C double bonded with O. But in the polymer, which is given here, that the shaded box is attached with O and the unshaded box is attached with C double bonded with O. So you can see if we try to compare with the polymers, two polymers which are formed by A and C, so A is the right answer. Like A matches with the polymer which is given to us. So the correct answer for this one is A.